Hello everyone. So in this video we have a question to solve. The question is fx is equal to 1 by x to the power 2x when x is greater than 0, and the question says that the fx is attaining its maximum value at x equals to 1 by e. So we have to find out which inequality is correct. So we have to use the calculus also to do this question. The aim of the video is to explain every aspect of this function. I will give you how to draw the graph of the function and how calculus is working in this question. So the question is clearly saying that the function attains its maximum value at 1 by e. So we can simply find out whether the function is decreasing or increasing around 1 by e. Means before 1 by e it should be increasing, and after 1 by 8 it should be decreasing because it's a maximum value. So the 1 by e value we take as our consideration point first. So we notice I have a pi introduced in each of the inequality given to check. It means we first simply assume that the function is increasing like that, and somewhere it is achieving its maximum value, which is supposed to be x equals to 1 by e in this question as it is given. So I will compare the e and pi. We notice that e is lesser than pi. So when I take the reciprocal of this, the 1 by e will become larger than 1 by pi. It means the function is strictly increasing. So I can clearly say that till 1 by e, means at 1 by e, whatever I get in the function, it must be larger than what I get at 1 by pi. So I substitute this value 1 by e in the function. So I will get it e to the power 2 by e, and this is pi to the power 2 by pi. In this way we get two different bases and with two positive powers, and the bases are also positive. I can remove this 2 both sides because we are taking the square root, and this is pi to the power 1 by pi will be left. Now I want to remove this 1 by e from here. It's clear that I can just take the power of this quantity as e. So when I'm taking this side, I have to take this side as well. So in this step, I'm getting e is greater than pi to the power e by pi. Now in the second step or second stage, I want to remove this pi from here. So what I take the pi as a power both sides. So e to the power pi is greater than pi to the power, this is pi not d, pi to the power e by pi to the power pi. So this pi will get cancelled and we get the straightforward, the inequality is e to the power pi is greater than pi to the power e. So that is the answer. We got the answer. And you notice if you are smart enough to find out the exact value, where so much fast calculation skill you have, or you can estimate e to the power pi and pi to the power e, what are those values, we can also compare without using this function. But what is the role of calculus? That is the aim of this video. Let's understand how this function look like graphically, and what are the other aspects. So I'm taking this function again here, and I have this function given fx is equal to 1 by x to the power 2x. I'm interested to know first that what is the approximate value of this function around 0. Means, in other words, I am interested to find out what is the limit value of this function at 0. So for that, I will take this function as e to the power limit x approaches 0, and that is going to be log 1 by x to the power 2x. What I have done? I've done nothing. I've just written this function in this way. Can I write this function in this way? Yes. e the power log x, means log 1 by x to the power 2x, because it will, after all, it will give the same thing back. So I'm finding the limit, so it's better to find the limit in this way. That's why I'm taking this. So in this way, what will happen? I will get e the power limit x approaches 0, and this 2x will come down by the log property, and this will give you negative of log x, because log of 1 by x, here this 2x topple down there. Now I have log 1 by x. What I can write log 1 by x as log 1 minus log x, and so log 1 will become negative sign, so log 1 will become 0, sorry. So this will give you minus of log x, or this x to the power minus 1 also you can write it, and you get the same thing here. Now when x tends to 0, this x times log x is going to be 0. This is nothing but limit x tends to 0, negative 2, it is on the power e, negative 2, and this is x log x. If you're preparing for JEE and all, you must know that this is the standard limits. When x tends to 0, x log x will become 0. So that is going to be e the power 0, that is 1. It means the 1 by x to the power 2x as the limiting value when x approaches 0 from the right hand side, in this case, is 1. Of course, this function is not at all defined for x less than 0 also. So here, the graph of the function fx will look like this. This is, let's say I have the point 1, 0, 1. So it's not exactly touching the y-axis at x equal to 0. Instead, it's just starting rising from 1. And as the question says that at 1 by e, it will attain its maximum value. So it will start rising and attain its maximum value at 1 by e somewhere here. And after that, it must start falling. But notice one thing as well, that when x is 1 in this function, if you substitute 1, it is again giving this 1 back. It means if 1 I'm taking on the x-axis somewhere here, it will fall and it will reach the same height. And after 1, what will happen? Due to the nature of this function, you can see when 1 by x to the power 2x given, as soon as you start substituting the denominator here greater than 1, this will become higher and higher, but the whole ratio will become lower and lower. It means it starts tending towards 0. It means at higher x towards infinity, this function has tendency to reach in 0. It means asymptotic to the x-axis. So this is the graph analysis of this function. Now we can observe by just drawing the graph, we can see that the 1 by pi should be here, because pi is a larger quantity than e. So if we are dividing this 1 by pi, so this will be lower than 1 by e. And from there we can again get the idea that f of 1 by pi should be lesser than f of 1 by e. Now, but the question one remains again, that how do we know that 1 by e is the point of maxima? Suppose the question is to you that find the point where the function is achieving its maxima. How do we find that thing? So you know, this 1 by e should be the critical number at which the function derivative should be 0. So I have the function fx. Again, I'm writing 1 by x to the power 2x. It means if I differentiate it and equate with 0, I must get x equals to 1 by e. So here, let's differentiate without using log. Instead, we are using this technique. We just write this thing as e the power ln, means log. I'm using it here in a different way. So this will give you fx e the power 2x, and this I already found it. So it is e to the power minus 2x log x. And let us differentiate it here only. So e to the power minus 2x log x, differentiation is minus 2x log x. And into the same thing, I have minus 2 and x log x. So x, you know that is a 1 plus log x. So this is our derivative of this function. This e to the power minus 2x log x will not contribute to produce 0 or any sign decision of the increasing decreasing behavior of this function. Therefore, I am ignoring it to find out the critical number, or automatically ignored, and f dash x equals to 0 when I substitute. I only get this factor 1 plus log x is equal to 0 to contribute something. Therefore, x will become 1 by e from here. You notice 1 will go this side with a minus 1, and log x is equal to minus 1 simply tells that x equals to 1 by e. Now, if x equals to 1 by e, we can also check the sign of this derivative function around 1 by e. So 1 by the better point, you can take 1 to check, and at 1 you get this value 0, this is going to be negative 2, and this value 0, so it will give you 1. Therefore minus 2 shows that after 1 by e is a negative, so that should be positive. And so it's clear that after 1 by e the function will start falling, and before 1 by e it was rising. Therefore 1 by e is the point of maxima. So this is the way we should draw the graph of function like this. We are actually ignoring the power of limit, but limit is a very crucial important tool which can decide how the graph of the function look like. We will see some other questions like this in other video. Till then, stay math active.